Welcome to this explainer on the Local AI Handbook, running powerful LLMs on your next smartphone locally. Let's just dive directly into this because we're looking at a massive, incredibly exciting shift right now. We're moving away from renting giant cloud servers and instead running genuinely powerful artificial intelligence right there in your pocket. We are literally witnessing a fundamental shift in computing for 2026. You know, the days of sending every single text prompt up to some massive distant data center, those days are starting to fade. Thanks to some absolutely incredible leaps in both hardware and software, we're rapidly moving toward decentralized, entirely on-device AI. I absolutely love this quote from the developers of the Pocket Pal app. It says, "Your AI, no one else's. This is AI you own, not AI you rent." I mean, that perfectly captures the massive stakes of this whole technological revolution, doesn't it? When you're running an AI model locally, right on your own hardware, you don't have to worry about a cloud provider analyzing your prompts, logging your personal data, or just, randomly shutting down their servers overnight. You are effectively taking back sovereignty over your own intelligence tools. It's yours, fully, completely, and offline. So here is our roadmap for today's deep dive. We're gonna hit 6 key areas. 1, the on-device AI revolution. 2, the hardware bottleneck reality. 3, the software magic quantization. 4, the developer deployment toolkit. 5, consumer AI apps today. And 6, the future of Pocket AI. Let's get into it. Starting off with section 1, the on-device AI revolution. Okay, so why even do this? Why move inference directly to your device? Well, it solves 3 massive headaches for you as a user. First up is latency. When you send a request to the cloud and back, it takes something like 200 to 500 milliseconds before you even see the first word. Imagine talking to a voice assistant, and every single time you speak, there's this weird half-second dead pause before it replies. It completely ruins the magic of a fluid conversation. But locally, responses are instantaneous. Second is privacy. Look, if your data never actually leaves your device, it literally cannot be breached in transit or stored on some server you have zero control over. And third, complete offline reliability. Whether you're hiking deep in the woods entirely off the grid, or you're stuck deep underground in a subway tunnel, your AI just keeps working. No signal required. Moving right along to section 2, the hardware bottleneck reality. Whenever we talk about running AI on phones, people almost always focus on the compute power. But honestly, that's not actually the issue. Think of your mobile neural processing unit, your NPU, as the engine. Modern NPUs from Apple and Qualcomm are insanely fast right now. They're pushing 35 to 60 trillion operations per second. So you've got a Ferrari engine. That's great. But the highway? Your device's memory bandwidth? It's incredibly narrow. A high-end desktop computer gets this massive multi-lane superhighway doing up to 3 terabytes per second. Your phone? It gets a single-lane dirt road at maybe 50 to 90 gigabytes per second. And since generating text is heavily memory-bound, because the chip literally has to read the entire model weight set across that narrow highway for every single word it generates, you hit a huge traffic jam. And then we have to face the brutal physics of heat. Mobile phones obviously don't have roaring cooling fans or giant heat sinks like a desktop rig. Research on the iPhone 16 Pro shows it can hit a blazing fast 40.35 tokens per second right out of the gate. That's incredibly fast, for about 30 seconds. But after just 2 consecutive queries, intense heat builds up inside that tiny glass and metal sandwich. So thermal throttling inevitably kicks in to literally keep the silicon from melting, and performance drops by a massive 44% down to about 22.5 tokens per second. Ultimately, your sustained AI performance is entirely dictated by how well your phone manages heat. Which brings us to section 3, the software magic quantization. So how on earth do we solve this brutal hardware bottleneck? We use software, specifically quantization. Think of it like a wildly advanced compression algorithm for the AI's brain. Now, AI models are typically trained in 16-bit mathematical precision, which takes up a ton of physical space. But by aggressively rounding off those complex numbers down to 4-bit precision, an industry standard often called W4A16, meaning 4-bit weights and 16-bit activations, we actually slash the memory footprint in half. This is huge. It means there is literally 4 times less traffic jamming up that narrow memory highway we just talked about. This translates directly to faster output, way lower battery drain, and surprisingly, the AI keeps its intelligence almost completely intact. It's like magic. This dynamic outlines what developers are calling the 2026 RAM crisis. Your phone's total RAM dictates exactly what tier of intelligence you can carry around. Think about the phone in your pocket right now. Remember, the OS itself hogs a few gigs just to keep the lights on. If you're rocking an older 6GB device, you're pretty much limited to tiny 1 to 2 billion parameter models like small LM3, which gets you a modest 5 to 10 tokens per second. The sweet spot right now is an 8GB device. That unlocks incredibly capable small language models, like Microsoft's 3.8 billion parameter 5.4 mini, running at around 10 to 20 tokens per second. But if you want to run those highly capable 7 to 9 billion parameter models, like Meta's Llama 3.27b, you really need a flagship phone boasting 12 gigabytes of RAM or higher.
Let's look at Section 4, the Developer Deployment Toolkit.
For the developers tuning in, you have to choose your weapons really carefully to actually get these models onto a mobile device. If you're building a massive production-grade app at, say, Meta's scale, you're going to reach for Executorch. It has a tiny base footprint and taps right into the PyTorch ecosystem for raw hardware delegate speed. On the other hand, if you just want ultimate flexibility and love tinkering with raw model files across different platforms, llama.cpp is basically the battle-tested gold standard right now. And if your goal is building a mobile-first app specifically designed around offline voice features like live speech-to-text, frameworks like Run Anywhere are proving to be invaluable because they wrap all that complex logic into super neat mobile SDKs. Okay, Section 5. Consumer AI apps today. The best part is, you really don't need a computer science degree to start playing with this right now. The consumer app market for offline AI is absolutely exploding. And there are amazing options you can download today. Let's look at 2. Pocket Pal AI is totally free, it's open source, and it works seamlessly across Android and iOS. Its real superpower is flexibility. You can browse and import hundreds of different Hugging Face models straight from the community. But then you have an app like Private LLM, which is heavily optimized specifically for Apple devices. It's written natively in Swift, meaning it runs incredibly fast on Apple Silicon. Plus, it has deep integrations with iOS features like Siri and shortcuts, so you can build some truly wild, fully off-grid automations.
Seriously, getting your own local AI up and running is astonishingly simple. Step 1, you just install an app like OffGrid. Step 2, download a model that perfectly matches your phone's RAM tier, like we talked about earlier. Step 3, and this is a massive pro tip from the dev community, dive into the app settings and switch the KV cache to Q40. That one little setting change gives you a massive leap in performance. And finally, Step 4, the ultimate test. Swipe down, turn on airplane mode, completely cut off your phone from the outside world, and just chat. I promise you, that is the true aha moment. You realize you're having a deep, complex conversation that is 100% powered by the silicon sitting right there in your hand. No cloud, no strings.
Finally, Section 6, the future of Pocket AI. Let me tell you, what seems impressive today is going to be the bare minimum tomorrow. With dedicated NPU silicon evolving at lightning speed, we're already seeing new chips like the Snapdragon 8 Elite pushing the boundaries of sustained output. At the same time, we're seeing hyper-efficient small language models, or SLMs, that genuinely rival the complex reasoning of models 10 times their size. And for the extreme power users out there who want to run massive workloads on their phone locally, there's actually a booming hardware market for external clip-on cooling fans to fight off that brutal thermal throttling we discussed earlier. The gap between your everyday smartphone and a dedicated desktop AI workstation is rapidly vanishing. For years, the immense power of artificial intelligence was locked away in massive, centralized server farms completely controlled by just a handful of giant tech corporations. But right now, today, the ability to generate text, write code, and reason through complex logic is shifting directly into your own hands. So I want to leave you with this. When your phone is smart enough to think entirely off the grid, without a monthly subscription and without a single bar of cell service, who really controls the future of intelligence? Thanks for joining me on this explainer. I highly encourage you to go download a local model today and experience this revolution for yourself. Catch you next time.